In the last session, I explained about classification of aircraft propulsion system. In this session, I'll explain about reciprocating engine working cycle, reciprocating engine components and their functions, operation of reciprocating engine, its advantages, disadvantages, and evolution of reciprocating engines to jet engines. First, we shall see about Otto cycle. Otto cycle is thermodynamic cycle which determines the functioning of reciprocating engine. PV and TS diagram for Otto cycle is as shown on the slide. Otto cycle consists of 4 processes. Those are isentropic compression, constant volume heat addition, isentropic expansion, and constant volume heat rejection. Now we shall understand how pressure, volume, temperature and entropy are changing during all these 4 processes. Process 1 to 2 is isentropic compression. Isentropic process is the process in which entropy is constant. In isentropic compression process, volume decreases which results in pressure rise from T1 to T2 and temperature rise from T1 to T2. Process 2 to 3 is constant volume heat addition process. Here at constant volume, that is from V2 is equals to V3, heat is added which results in increasing entropy from S2 to S3 and temperature rise from T2 to T3 and pressure rise from P2 to P3. Process 3 to 4 is isentropic expansion. Here also entropy is constant and volume increases from V3 to V4 which results in pressure to decrease from T3 to T4 and temperature also decreases from T3 to T4. Process 4 to 1 is constant volume heat rejection. Here volume is constant, that is V1 is equals to V4. As heat is rejected, entropy decreases from S4 to S1 and temperature decreases from T4 to T1 and pressure decreases from T4 to T1. Next we shall see the parts of reciprocating engine. The major parts of reciprocating engine are as shown on the slide. They are inlet valve, exhaust valve, cylinder head, crankshaft, cylinder, combustion chamber, piston and connecting rod. Now we shall discuss the functions of all these components. Intake valve. The function of intake valve is that it takes in air-fuel mixture inside the cylinder. When the piston moves up, it reaches the top dead center position. BDC is the bottom dead center position. When the piston is pushed down, it reaches bottom dead center position. Cylinder, its function is it takes in air-fuel mixture and air-fuel mixture is burned inside the cylinder and power is generated. Crankshaft converts reciprocating motion of the piston into rotary motion. Exhaust valve, as the name suggests, it removes the burned gases from the cylinder. Combustion chamber, its function is combustion process occurs in this combustion chamber which is near the top dead center of the cylinder. Piston, it moves up and down inside the cylinder or reciprocates inside the cylinder and compresses the air-fuel mixture. Connecting rod, it connects the piston and the crankshaft. Next we shall see the operation of reciprocating engine. Reciprocating engine operates on 4 stroke cycles. First is the intake stroke. During this stroke, inlet valve opens and exhaust valve remains closed. Piston moves from top dead center to bottom dead center, creates suction. Hence, air-fuel mixture is sucked inside this compression stroke. During this stroke, inlet and exhaust valve remain closed. Piston moves from bottom dead center to top dead center, and the air fuel mixture is mixed and compressed. Spark plug ignites the mixture and combustion process takes place. Next is the power stroke. In this stroke, the inlet and exhaust valve remain closed. After ignition of fuel, tremendous amount of heat is generated, causing high pressure inside the cylinder, which pushes the piston downward. The movement of the piston at this instant is called power stroke. Piston moves from top dead center to bottom dead center in this process, and burned gases are expanded. Next, the last stroke is the exhaust stroke. During this stroke, piston moves from bottom dead center to top dead center, and the burnt gases are thrown out from the exhaust valve, and the cylinder becomes ready to receive the fresh charge. During exhaust stroke, the inlet valve remains closed. Next, we shall see the advantages and disadvantages of reciprocating engine. The advantages of reciprocating or piston engines are they have quick starting capabilities, means the piston engines can start and stop quickly. They have high thermal and electrical efficiencies. Piston engines are simple in construction, which means they require low maintenance and low manufacturing cost. Disadvantages of piston engines are that compared to jet engine, piston engines are complex in construction, and piston engines are used in aircrafts which fly at low speeds and low altitude. Piston engines have poor fuel economy. Piston engines are not used in aircrafts because of their heavy weight, noise, and high emissions. Let us see few applications of reciprocating engines. Reciprocating engines or piston engines are used in small automobiles and can work on different types of fuels such as petrol. Next, we shall see the evolution from reciprocating engine to jet engines. R4360 engine is a reciprocating engine. JE9X engine is a jet engine. Since 1950, piston engines had reached their peak of development. Piston engines were light, powerful, reliable, and fuel efficient, but they had reached their peak of complexity and provided low power. So, the development began to produce greater potential engines like jet engines. With this, I end up this session here, and in the next session, I'll be explaining about turbojet engine. Thank you.